Good morning. Welcome to Lesson 18, Compound Events. We're going to start with example 1 on page 422. And we also start out with this idea of sample space. Sample space is the set of all possible outcomes of one or more events. And so in example 1, we have to find the sample space. And so by looking at this example, the end result is the outcome, which is that sample space. So it's all the different kinds of pizzas that you could get. So one way to find the sample space is to do a tree diagram. So notice off to the left, we're given 2 different kinds of crusts and then 4 different styles of pizza. And so they've used this tree diagram to come up with all the different types of pizza. So you can have thin Hawaiian, thin Mexican, thin pepperoni, thin veggie, and so on. And then you do the same thing with stuffed, making sure that everything is accounted for. Then off to the side, you can see all of the possible outcomes, which is that sample space. And then your final answer is there are 8 different outcomes in the sample space. And so then we know that there's 8 different pizzas that we could order. So it's pretty straightforward, but it is actually identifying what each of the options are. All right, so moving on to another key idea on page 422, we have this idea of fundamental counting principle. And so this is another way to just find out the total number of possible outcomes. So if you don't need to know what the outcomes are, just how many outcomes there are, how many possibilities there are, you can use this fundamental counting principle. And what that is saying is an event M, so whatever the event is, has little m possible outcomes. An event N has n possible outcomes, right? So the total number of outcomes of every m followed by event N is m times n. Long story short, if we go back up to the example that we just finished, if we only wanted to find the number of possible outcomes, we have 2 different kinds of crusts, right? 2 different kinds of crusts and 4 different styles. 2 times 4 is 8. We have 8 possible outcomes, which were the 8 different types of pizza. Okay, so that's the fundamental counting principle. I know the way that the book describes it is a little convoluted. However, all it is saying that we are going to multiply the numbers. So 2 different types of crusts, 4 different types of styles, 2 times 4, 8 total different types of pizzas. All right, moving into examples 2 and 3 on page 423, we're going to start with example 2. And with example 2, we are actually looking at 2 different possible methods to utilize. One is the fundamental counting principle. The other is using a table. And so what we're wanting to do here is find the total possible outcomes for this idea of both flipping a coin and for rolling a number cube. So as you can see in the table, it gives a good visualization of what's actually occurring, and it also is showing you what the actual possible outcomes are. So looking at the table, you can see that your first option is rolling a 1 and a heads, flipping a heads. Below that is a 1 and flipping a tails. To the right of that, rolling a 2, flipping a heads, and so on. So as you can see, there are 12 possible outcomes. All of the 12 outcomes are listed, giving you that sample space. Now, method 2 is going to be a little bit more simple, and it is only going to give you the information of how many outcomes there could be. And so that's using the fundamental counting principle. With heads and tails, you have 2 options. With rolling a cube, you have 6 options. So 2 times 6 is equal to 12, which gives us then that 12 possible outcomes. All right, so moving on then to the next example. We see that we want to know how many different outfits the person can make. So they have some t-shirts, and they have some jeans, and they have some shoes. And so looking in the closet, you can see that they have 4 different pairs of pants, of jeans. They have 7 different pairs or t-shirts, and then they have 3 different possible shoes. And so when we use that fundamental counting principle, we have just 7 times 4 times 3, which then leads us to that final answer of 84 different outfits. All right, looking at examples 4 and 5, we're going to start with the word compound events. Compound events actually only mean that there are 2 events happening. So we've been kind of talking about those earlier when we have been looking at flipping a coin and then rolling a die. And example 4 is just that, flipping a coin and rolling a die. This goes back to example 2, where you actually wrote out in that first method the entire sample space. And so with this, we want to know what the probability of rolling a number greater than 4 and flipping a tails. And so for this, you go back to that graph that we created, and we can see that there's a 5T and a 6T, right? Rolling a 5 and getting a tails, and rolling a 6 and getting a tails. And so those favorable outcomes, that's 2 out of 12, right? There were 12 possibilities. So that simplifies to 1/6. All right? So that's one way to be able to find that out. Moving on to example 5, we see that we're going to use a tree diagram for this because we want to flip 3 nickels, and then we want to know what is the probability of flipping 2 heads and 1 tail. And so they did the diagram for you. So the first time you could do a heads, and then a heads or a tails, and then a heads or a tails off of each of those. And so then in that final column that's all colorful, the red, blue, and green, it has HHH, so it's heads, 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 or it has heads, heads, tails, or heads, tails, heads. And so it has the entire sample space for you there, and this makes it a little bit easier for you to be able to see what the favorable outcomes are. Again, we wanted to know the favorability of flipping 2 heads and a tails. Order doesn't matter, so it could be heads, heads, tails, or heads, tails, heads. It didn't matter the order, it was just 2 heads and a tails. And so you can see that they circled the 3 heads, heads, tails, and that was out of a total of 8. So the probability of this happening is 3 out of 8.